Hello, everyone, and welcome back to the Applied Medical Statistics playlist, which targets all healthcare professionals and board exam takers. This playlist covers the essential statistical concepts, and this presentation is about the data and variables. We'll talk a little bit also about measurement scales. So let's get started. In general, statistics, as you all might know, is a branch of mathematics which focuses in condensing the characteristics of large data sets that we have and turn it into meaningful conclusions. And it's basically done through studies that collect data, organize it, summarize it, analyze it, and draw conclusions out of that. The aim is to make decisions for better future. That's in general. So the main idea of statistics is to collect data and to reach some conclusions. These are the two keywords here. So the branches of statistics, the two main ones are descriptive and inferential statistics. And as the names imply, descriptive statistics just describe a situation or a group of population, the characteristics, summarize that group characteristics, depends on what are we studying. And the aim really is to make some inferential or generalization of that sample results to the whole population, because it's hard and costly to study all the population all the time, right? The only situation where we study all the population is the censuses, where usually it's done every 10 years, for example, to collect baseline data about the population in general. So the descriptive statistics helps us to make that inferential to the big population based on the results of this group that we studied, right? And not to forget to mention that the word data or data can be said both ways. You can say data or data. It's not a big deal, but it's a plural word. So this is usually creates some confusion when you write about data or data. You better use R, because data is the plural of datum. It's a Latin word. Datum is the singular and data is the plural. So it's the facts or the observations that we collected from our studies, from our descriptive statistics. And as I said, the aim is to make that generalization, right? So what we collect are the variables. And variables are very important in statistics and research studies in general. So there are many classifications for variables. We can divide variables into dependent and independent. And also the name explains everything. So independent variable means it's not affected by the results that we are seeking to find. It's the independent. It's the variable that we are studying and that leads or somehow affect the outcome. So the input or the item that we are studying, it's the independent variable. And the outcome or the results that we are looking for through our study is the dependent variable. For example, if we are studying the impact of smoking on risk of getting cancer, so smoking here is the independent variable, and the outcome getting the cancer is the dependent variable, right? So it's not all the time independent when a variable at certain study is independent variable, it doesn't mean this variable always is independent. I mean, independent or dependent depends on the way that we design our study. So for example, smoking can be the independent variable if we are studying the effect of smoking in the risk of getting cancer, or it can be dependent variable if we are studying the impact of age in smoking habit. If we want to study the smoking habit among high school students, for example, we want to see the impact of age, which age group are smoking more. So in this situation, smoking is the outcome. We are studying the impact of age and smoking. For example, what I wanted to confirm here is that being dependent or independent variable, it depends on the study design itself. But in between the independent and dependent variables, many variables intervene, like moderating variables, control variables, confounding variables. These are variables that sometimes the researcher does not count for them while designing their study, but in a way they impact the results or they impact the independent variable itself. So let's give some examples. So for intervening variable, if we are studying or testing the impact of income on the lifespan, right? So in this study, the income is the independent variable and the lifespan is the outcome or the dependent variable. But some intervening variable, like access to healthcare, is affected by your income, right? And it affects also the outcome, which is your lifespan in a way. So in this way, if we don't consider that during our study design, and put this access to healthcare as one of the variables that we are studying, it will be as intervening variable, right? Also, for moderating variable, the moderating variable basically change the relationship between the dependent and independent, either weaken that relationship or strengthen that relationship. For example, the impact of income on job satisfaction. Here, income is the independent variable, the job satisfaction is the outcome or dependent variable. But there is one moderating variable we need to consider here, which is the family size. So it depends how many family members that you have. So that income is enough to afford life with this family size. So you will have job satisfaction or not. In this case, the family size is a moderating variable that affects the impact of income in job satisfaction. Also, we have the control variables. These are variables the researcher aware about them and control them before starting the research and make sure they are equivalent in both the study groups, for example, if they are doing case control study, let's say. So, for example, if we are studying the impact of one medicine in a specific disease, we have to control for the participants' diet to eliminate the effect of diet in that disease. For example, hypertensive drug, we know that certain diets affect the blood pressure, right, and might lead to high readings. So if we want to eliminate the effect of diet in this study, we control that. We give both groups exactly same diet during the study time. Lastly, we have the confounding factor or variables, and the most famous confounding variable is age, because the confounding variable basically impact both the dependent and independent variables. So usually it needs to be also be considered at designing our study. If we take the example of a smoking effect on risk of having lung cancer, we know that smoking affected by the individual age. Usually it's high prevalence in young age groups, and it affects your probability of getting cancer because as early as you start, you will be exposed to tobacco for long years, so that increases the outcome as well, which is a dependent variable. So this is in brief some types of variables. Moreover, the classification of variables can be based on their nature, whether they are quantitative or qualitative variables. And again, the name explains everything. Quantitative means there is quantity. We can count that by numbers, numerical. And that's basically the meaning of quantity, right? And qualitative means it's non-numerical and it's usually categorical. We use words to describe the qualitative variables. For the quantitative variables, they can be discrete, which is distinct numbers, like no fractions, and the continuous is infinite numbers that accept fractions and decimals. Let's give an example. If we are describing a human being or a participant in a study, that description includes quantitative variables like we can say this person has, for example, simple description, 2 eyes. The number is 2. It's a discrete number. We can't say 2.5 eyes, right? 1 mouth. We can't say 1.5. 2 hands and 2 feet. We can't accept any decimals in this discrete number. This is the type of discrete quantitative variable. But in other way, we can describe the individual in terms of weight and height that accept decimals. So the height of the person can be 159.5 centimeters, or for example, the weight of the patients can be 180.3 pounds, right? So these are continuous number, can accept any number, infinite numbers are the options. The qualitative, as we said, it's distinct. It's just descriptive word options. For example, the gender of this individual, either male or female, the ethnicity, we have certain types or options for ethnicity, and so on. This is qualitative variables. So one step ahead after variables, we have the measurement scales. And the measurement scales sometimes get confusing, but we have 4 scales for variables. And it's important to know the measurement scales for our variables because it's very important in data analysis and the way that we depict our data. The infographic in most of the analysis softwares, it requires you to know the type of your variable. So let's explain them simply. Nominal, the first scale is name. It includes name, right? And the nominal usually for the qualitative variables. So as we give the example of the gender, male, female, this is nominal scale. And it can be 2, like dichotomous, 2 options for that variable. Or when we come to classify our variables and getting our data ready for analysis, it can be non-dichotomous, like multiple options. For example, the ethnicity, usually it has like 5 options, black, white, Asian, or Hispanic, non-Hispanic, more than 2. This is still a nominal scale measurements. So for ordinal, the second measurement scale that we have here, it's a scale that has certain options right? And there is a logical order for that. It goes from high to low, or from less to more. So there is order, not like the nominal. Nominal, there is no superiority or inferiority being male or female. It's just descriptive, right? What's your ethnicity? It's just descriptive. But the ordinal, it measure or scale your option based on which level is higher than the other. The most famous one is the ranking scale. When you ask the participants, do you agree with this? For example, if we ask about this lesson or this video, do you think it's useful or informative? And the options will be strongly disagree, disagree, uncertain, agree, strongly agree. For example, this is ranking or ordinal scale. The last two scales, interval and ratio, are usually for the quantitative variables, right? The interval, as the name says, there is interval. The interval between point A and point B is there fixed. And a good example of that, the temperature. If we are checking a patient temperature today, it's 38. Tomorrow we find it 40. There is interval between the 38 point and the 40 point, and that's interval is fixed. Here it's 2, but it doesn't mean we can make a ratio between 38 and 40. We can say that the difference between yesterday's temperature and today is 38 over 40. No, it's just interval between the two readings. The ratio is totally different, and the most characteristic thing for ratio scale is that 0 is meaningful. So for example, if we are checking exam scores for students, 0 means you failed the test, right? 80 means you got high score. If you are checking the weight per kilograms as a ratio, you say your weight is 100 kilograms, right, for body mass, and so on. So if you say the weight of this paper is 0, that means it's so light that its weight is 0, and so on. This is the ratio scale. And as I said, this is important to determine what kind of scale you are using during data analysis. Well, I hope this at least gives some explanation about the main types of variables and the scales that we use for data analysis, and a little bit of information about data itself and statistics. For further information, you can check this reference. It's a good one. And thank you so much. Please give me any feedback or suggestions for future videos. Thank you so much.